Hello, students, and welcome to 322 Exploring an Area Model. I'm sorry I couldn't be there today and that I missed algebra tiles yesterday. However, the purpose of yesterday's lesson was really an intro to the real lesson, which is today, area model. So let's take a look. Today's target is to essentially create these area models and write them as a sum of their parts, as well as the product of their dimensions. So we'll be in your textbook today on page 155, and we'll do exercises 84 to 88. And we'll do some stopping of this video so you can write down some work and responses, and we'll also do some modeling. All right, we'll start with number 84 together as a class here. So number 84, you don't need to copy anything down, but the directions are the following. We want to write the area of this area model, and you've never studied algebra tiles, so let me give you a little bit of information about this. Each algebra tile that you see here is labeled X, Y, Y. That means all of these are Y as well. These are all X's, and these are all just 1 by 1 squares right here. This is an X squared tile, and these are X tiles as well. All right, so we can model the area of this rectangle by writing out the dimensions of this rectangle. For example, the top part of this rectangle is y plus x plus 2. And the side dimensions of this rectangle, well, these y tiles are 1 by y tiles. So it's really just 1, 1, 1, 1. And this is an X by Y tile. It's X on the side, Y on the bottom. So this is really X plus 4. That's how tall this rectangle is. So you can write the area as a product. And that means X plus 4 times Y plus X plus 2, like that. You could also write the area just by adding up all the tiles you see in this picture. We call that the sum. So this first way is the product of the dimensions. Second way will be the sum of the parts. So we're just going to count. So we've got 1y, 2y, 3y, 4y. We only have one xy tile. 1, 2, 3, 4 x tiles. One x squared tile. 2 more x tiles, and 1, 2, 3, 4, 5, 6, 7, 8 individual tiles. Okay, we'll simplify this by combining any like terms we can. Obviously, these can be combined. Nothing else can. And we'll take that larger exponent, bring it out front like this. Otherwise, the order really doesn't matter here. But there you go. That's the sum of the parts right there. Okay, so these two both represent the area. This is the area as the sum of the parts. This is the area as the product of the dimensions. If we were to multiply these things out up top here in the product, we should get the sum of the parts. All right, well, let's go on to the next video right here, or the next example. And let's have you try this one out first by identifying what are the tiles we're working with here. Let's take a look. Again, I realize it wasn't there to help you identify these yesterday, but these are all x squared tiles, which means it's an x by x are the dimensions. So the area of these tiles is x squared, and x squared. So that makes all of these x tiles, or 1 by x tiles. And so are all these, a bunch of x tiles as well. A whole lot of those. And these are all individual 1 tiles right here, 1 by 1. So their area is just 1. The x tiles are 1 by x, so their area is x. So to write these as a product of its dimensions, we need to know the dimensions. So this is 1, 2, 3, x, and x. So that's 2x plus 3 is the first dimension of this rectangle. On top here, I got x, 2x, 3x, 4x. plus 1, 2, 3, 4, 5. So the area as a product of its dimensions is equal to 2x plus 3 times 4x plus 5. Now the area as a sum of its parts, if I just sum up all the areas you see in green here, we would just count. How many x squared tiles do we have? We have 8 of them, so that's 8x squared. How many x tiles do we have? We've got 3, 6, 9, 12. And then we have 10 more to add to that, so that's 22x tiles. And then how many single tiles do we have? We've got 5 rows of 3 or 15 single tiles. So those two would be equal to each other if you were to multiply out the area of the product. Okay, so those are two examples using algebra tiles that you did not have a lesson on yesterday, but the real purpose is to now transition into what's called an area model. So that's coming up next here. So 86. Take a look at 86 and take a moment to examine the diagram that you see over here on the left side of the screen. How is it similar to the algebra tile diagram we did in 385? How is it different? Talk with your teammates and write down all your observations about how it's similar and how it's different. I'll pause the video and then come back. Okay, if you pause the video and have had some time to share, now's a good time as a class to share out some noticings. How are they different? Well, you might have noticed or commented that one is made of algebra tiles and one is not. How are they the same? Well, you might have noticed that their dimensions are exactly the same that you see. The dimensions listed here on the left side, 4x plus 5, are the same as the dimensions of this rectangle made of algebra tiles. And 2x plus 3 is the same as these dimensions on the side here. So we're essentially saying instead of using algebra tiles, we can use an area model, which is a much simpler picture than having to play with these tiles. Okay, so let's put it to practice finally. In 87, as a class, take a moment and copy each of the rectangles or the area models you see below onto your paper. So pause this video and let's come back once you've copied down each one of these, and then we'll work through these as a group. Okay, I hope you've had a moment to copy down each one of these. If not, pause the video and copy down the area models. Let's take a look at part A. Part A, we already have the dimensions right here. That's what these are on the side. These are the dimensions of this area model. To fill in the inside of this area model, we have to multiply these dimensions times each other. So first, the area as a product would just be x plus 5 times 2x plus 3. But the area as a sum is adding up the pieces on the inside. So here we go. Just like a multiplication grid, we're going to multiply this by this to figure out what goes inside there. So x times 2x is 2x squared. X times 3 is 3x. Let's go to the bottom row. 5 times 2x is 10x. And 5 times 3 is 15. If we add up those pieces and combine like terms while we do this, like 3x and 10x make 13x. We have the area as a sum of its parts and the area as a product of its dimensions. So that's part A. Pause this video and try completing these on your own with your teammates, and then we'll come back together and go over the solutions. All right, let's see how we did here. Here are the solutions to each of these area models. In blue, you'll see the area written as a sum of the inside parts. In red, you'll see the area written as a product of the outside dimensions. So there's part B. I'll just zoom into each one of these and zoom back out. You can see part C involved combining some like terms I highlighted in yellow. And then part D was just a little one. So maybe you're starting to notice the area of the sum is just multiplying the red things together. That's what's happening. Okay, let's move on to number 88. So now you were given the area models in 87 and had to come up with the product and the sums. Now it's your turn to draw the area models. So we're going to do a couple of these together, and then the rest will be on your own, and you'll be able to check your solutions after pausing this video. Okay, so in part A right here, these area models, the rows and columns depend on how many terms you have. For example, this is a 2-term and another 2-term item. We call those binomials, where this is 1 term and this is 2 terms. So that means you're going to make a 2x2 table here and a 1x2 table here. Another 2x2. Here will be a 1x2. Sometimes you have a 2x3. Here's a 2x2. So that's your first clue here. So for part A, we're just going to draw a 2x2. If I could draw a box, that would be helpful. Okay, that'll work. It's not pretty. We'll take it. On the outside, go ahead and put x plus 2 and x plus 1. There's your area model. Now you just need to fill it in by multiplying. X times x is x squared. X times 2 is 2x. Now go to the bottom row. X times 1 is just x, and 2 times 1 is 2. So then you can write the equation showing the area as a product equals the area as a sum. So here we go. We've got x squared plus 3x plus 2 equals the product version, which is x plus 1 times x plus 2. So there goes part A right there. In red, you've got the sum. In blue, you've got the product, and they're equal to each other. So that's your job for B all the way through F. So pause this video and we'll return to go over the solutions. Okay, before we go over the solutions on screen, I invite you to do a swap meet and share your findings for number 88. So that means you can swap your facilitator and recorder reporter, for example, with another team and share what you got for 88, and then return back to your tables in about 2 minutes. Okay, done with the swap meet? Nope, need more time? All right, pause the video and do your swap meet. And then press play when you're done, and then we'll go over the solutions. So I'm assuming your swap meet's done. So here are solutions to 88. These are all the areas written as a sum of the parts inside the area models. So check your solutions, pause the video right here, and then we're going to wrap things up. Okay, can you represent algebraic expressions using area models? Maybe yes, hopefully yes. You only get more confident the more you practice this. Your next steps are, well, there's no homework. Happy Friday. And don't forget shots for Smarties, and you only get a candy if you made it. All right, that's the rule. Have a great weekend, everyone.